in, two, and in one. Today, I'm really excited. We are gonna learn all about colors. Everyone say colors. Colors. And earlier this week, I told you to wear your favorite color. Let's have a few friends share out. Raise your hand. What's your favorite color? Jamil, what's your favorite color? Green. Mayori, what's your favorite color? Pink. Missouri, what's your favorite color? Pink. Akir, what's your favorite color? Blue. Sincere, what's your favorite color? Well, who here's ever wondered, like, where does a color even come from? Today, you're gonna be able to answer that question. You're gonna be able to go home and explain to your families and your friends why not only you can see certain colors more than others, but why your shirt is pink, why your shirt is green, why the desk is blue. You are going to be able to explain this. And now one place where we see a lot of different colors is a rainbow. Give me a thumbs up if you've ever seen a rainbow in the sky, on TV, on camera, in a cartoon. I want you to think for about 15 seconds, where do you think a rainbow comes from? Think for about 15 seconds. Where do you think a rainbow even comes from? Where do rainbows come from? Think about where you see them. Think about our unit so far. Make a prediction based on the knowledge and what we've been talking about. Take about 10 more seconds. 10, 9, 8, 7, 6. Where do you think rainbows come from? 5, 4, 3, 2, and 1. Take 1 minute. Turn and talk with your group. Share, where do rainbows even come from? Ready, set, go.
I think they form when it's done raining. Rainbows come from like a source of something that puts it like together and then like it just makes a big colors in the sky.
Like it's probably like I think it's like a shine from the sun.
Okay, you think it has something to do with the sun? Akira, what do you think?
Same as him. I think too because most of the time like I be certainly outside it be rainbows everywhere.
Okay, when do you typically see a rainbow?
Like on the ground and stuff.
Okay, so maybe like the end of a rainbow?
Goes into liquid and the liquid slows down.
And let's have two friends share out. Where do you think a rainbow comes from? Jamari, where do you think rainbows come from? Okay, rain, sunlight, clouds. Asada, where do you think a rainbow comes from? Let's have one more friend share out. Kyer, what do you think?
I think rainbows come from water and rain.
Okay, so I'm hearing water, rain, sunlight. And where do we typically see rainbows? We see it in the sky. Yeah, in the sky. And today, during our read aloud with Samuel and Jack, we're gonna be thinking about what causes a rainbow. And at the end of our read aloud, your exit ticket is going to be able to answer, well, where do rainbows come from? But first, we're gonna start with our reading. And what I want to do is I want to activate some prior background knowledge on a very specific vocabulary word that you are going to be using. White light.
White light.
Back in our very first chapter, we learned about white light. I want you to think for about 15 seconds. What do you remember about white light? What do you remember about white light? Think about where it comes from. Why is the name a little bit deceiving? And let's have a few friends share out. What do you remember about white light? Heaven, do you remember something?
That white light has most of the colors.
Ooh, did you hear what she said? Heaven, say it a little bit louder.
White light has most of the colors.
So is white light actually white? Anyone else want to share out? What else do you remember about white light? Jamari, go ahead. Okay, it comes from the sun. So the light that will hopefully be shining in our room in about 30 minutes comes from where? The sun. So I want you to think about those ideas as we are reading today. And what we're gonna start is with a closed reading, where we're gonna do some independent reading and writing down key details. So what I'd like you to do is please take your small book, grab your big book. Our reading today is all about color and light. Everyone say color. Color. And light. And as we're reading chapter 5, our goal is to look for key details about color and light. And what do we always do to make sure that we remember those key details? Whisper it to a neighbor in 3, 2, 1. Say it out loud in 3, 2, 1. Get it, Javion. We underline, but we're taking a step farther because we're scientists, and we know that underlining as a scientist isn't enough. We're gonna be doing an experiment later, and we need our lab notes. Everyone say lab notes. Lab notes. We're gonna be referring back to our key details from our reading today in order to explain why our experiment happened. So the first step is gathering those lab notes. So in your small book, please turn to chapter 5. And in your big book, please turn to page 49. In 5, in 4, in 3, in 2, and in 1. Here is going to be your job. You are going to have 15 minutes. We're gonna start with 15 minutes. If we need more time, I will give you more time. Your job is to read a selected amount of pages. We're not gonna read every page, we're gonna read a few. And your job is to underline those key details about color and light, so that when we have our experiment, you're gonna be able to explain the results. Now, I'm gonna tell you which pages you're gonna read today and where you are gonna write those key details. So I want you to pick up your pencil and you're gonna circle it so it is very clear which pages you are reading and which spaces you are writing down your key details. Everyone circle 56, 57. Circle 58, 59. Circle 60, 61. Circle 62, 63. Now, if you finish before the timer goes off, these last 2 pages are gonna be the challenge. If you get there, amazing. If you don't, that is okay, but I want you to think of the last 2 as a challenge. What I should be seeing as you are reading is, everyone say number 1. I'm underlining key information about light and color. Number 2, in my graphic organizer where I have my lab notes, because like I said, scientists use research and experiments in order to gain knowledge, I'm going to be writing down 1 to 2 facts from that group of page. And what I'm gonna think about is, does this fact give me information about light and color? Does it give me information about light and color? We are gonna be reading and working independently unless you come usually work with me at the L table. Give me a thumbs up if you've got it. If you come to the L table to read with me, please bring your big book, your small book, your pencil. Everybody else, you are going to have 15 level 0 minutes to read, underline, record your lab notes. Ready? Get set. And we'll wait till everyone's at my table. Go. Alrighty, make sure you are on chapter 5 if you're not already there, and page 49. We're gonna follow a very similar process, just like we did when we read Stella. When I was reading it to you, you were doing the underlining, you were doing the note tracking. So what we're gonna do is I'm gonna read. If you hear a key fact or a key detail about what 2 things?
Light and
What was light and color? You're gonna go ahead and do what? You're gonna underline it. We're gonna take a minute. Abdullah, put your pencil down. We're gonna take about 2 minutes at the end of these page, and if there is something that you underline that you wanna stop and jot in your note tracker, you're gonna do that. Got it? So pick your pencils up, getting ready to underline. Don't worry about this page until we stop and jot, okay? All right, here we go. You ready? Do you remember what color sunlight is? Hopefully you didn't say no color. You learned that sunlight is white light. You also learned that instead of being no color, white light is made up of all the colors of the rainbow. Remember, the sun looks yellow because it gives off more yellow light than it does the other color. I can see Nate started taking his pencil, he started underlining. Nate, did you hear something that was important? What do you think you heard that was important? Let him answer, hold on.
White light is made up of all
What? All what?
the colors of the
Which word are you at? Let me see. Yeah, white light is made up of what? All colors. I heard in that sentence the 2 words that we are looking for today. So Nate, did you feel like that was something important? Yeah, that involved both of our vocabulary words. So I am gonna assume, just like Nate, that's gonna be something that I'm gonna wanna remember. White light is made up, oh, Akira's already got it. And just like Nate was doing, you should be underlining as I'm reading. If you hear something, you're like, I need to remember this, underline it. All right, put your finger on you. We're in the second paragraph, so I know that you are with me. You can prove that white light is really many colors if you have a wedge-shaped piece of transparent glass called a prism. If you hold a prism near a sunny window, light will shine through and make a rainbow-like band of colors. This shows that white light is really made up of all the colors. Now I want you to think about what you underlined. Where it says pages 56 and 57, I want you to record your key details in that space. You're gonna need this when we do our experiment later. So take 2 minutes, record your key details in the first space. Ready, set, and go. Go back to the other page. You should be recording what you underlined within your graphic organizer. Turn back to the page. What does this tell you about light and color?
prism.
What does that tell you about light and color? Ask yourself that question. If you're unsure if it is a key detail, something that you should be recording, Nate at my small group, we talked about it. He said, well, the reason I underlined a key detail was it told me information about both light and color. So a question that you can ask yourself as you're underlining and writing in your graphic organizer is, does this teach me something about light and color? Make sure you're recording as you are writing. Alrighty, give me a thumbs up if you finish writing your key details down. Awesome. Turn to the next page in 5, in 4, in 3, and 2. Ooh, what do you see on this next page?
A rainbow.
Do you remember what you learned about refraction? What happens to light when it passes through something transparent like glass? This is what creates a rainbow. Take 2 more minutes. In 58 and 59, you are going to record another key detail about light and rain. Light and what?
Light and colors.
All right, go ahead, 2 more minutes.
We got it.
Let's take about 6 more minutes. If we need more time, we will when we get there. You guys are working so hard. Can I ask you a question? You already started underlining. What made you think you should underline something? How do you know something's a key detail? You saw something that made you underline. Do you remember what that text feature is called? Yeah, so Akir knew already, and Antonio, I love that you remember that bolded words typically tell me things that are important to remember. And although I love that you're excited and you want to underline it, a bold word is a great key text feature to look for to know that something is probably important for me to remember. All right, you guys ready? When white light is refracted, it often separates into a combination of colors called the spectrum. The colors in the spectrum always appear in the same order: red, orange, yellow, green, blue, indigo, and violet. These colors are part of visible light spectrum. They are the light waves that humans can see. The colors of visible light are a result of differences in wavelength. Red light has long wavelengths and violet light has short wavelengths. Where can we see that? Look around the room. Where can you see the different wavelengths and the different colors? Yeah, and if you look at the knowledge wall, you can see right under light and sound. Show me with your arm, what does a red wavelength look like? What does a violet wavelength look like? Yeah, the red are much longer and the violet is what? Much shorter, quicker together. We're at you in the second paragraph. You can remember the names of the colors in the visible light spectrum in the right order if you can remember this funny name. Ready? Repeat after me and whisper it. Roy.
Roy.
G. Biv.
Biv.
Say it again. Roy. G. Biv. Each letter in the name stands for a color in the rainbow. Say it one more time. All right, here's what I want you to do. Take 2 more minutes, write your key details down under 60 and 61. Can I see what you're writing? Can I see this? Good job, Logan. Good, keep going. Your key details are great. Make sure you're writing down the entire key. Can you flip back a page? I want you to read what you wrote for 60 to 61 and ask yourself, did I write down everything that I need to understand this fact? All right, you ready? Go to the next page. You're all right. Alrighty, last one. You ready? Did you know that the color of any object depends on what wavelength it reflects? Different objects absorb light wavelengths of some colors. Black. Things that appear black do not reflect any light. They absorb all the light wavelengths. Take 2 more minutes, record your final key details in 62 and 63. So for example, you started underlining up here, right? That's where you heard something important. I'm gonna start exactly where my underlining was. Got it? Where are you, what detail are you underlining? Okay, what I see is that you're underlining part of a sentence here and part of a sentence here. If you think that this whole sentence is a key detail, what should you be writing? Why just part and part? We're writing down the whole sentence. You thought this whole sentence was enough? So I'm gonna underline the whole sentence because that whole sentence is a key detail, not just the parts. Think if you were watching a movie and you only got a part of the middle and the end, would you know what it was about? Would you? Nope. So our key details are the same. We underline the whole thing. Alrighty, here's what I want you to do. Give me a thumbs up if you found so many key details, and I'm looking around the room and we gathered so much scientific research about light and color that a lot of us pulled out similar information, but different information as well. And scientists not only find information themselves, but they talk to other scientists. They see if they can help one another. So I want you to take 1 minute. I want every member of your group share one key detail about light and color that you found interesting today. Ready, set, and go.
One key detail that I found that I think is interesting is different objects absorb light wavelengths of some colors but reflect others.
I found a key detail. One key detail that I found that I think is good is white light is made up of all the colors of the rainbow.
A key detail that I think is good is if you hold a prism near a sunny window light, it will shine through and make a rainbow like a band of colors.
Let's have a few friends share out. What did you learn today about colors and light? Miracle, why don't you start us off?
When white light is reflected, it often separates into a combination of colors called the spectrum.
First off, give Miracle some shine. She found an amazing fact. We learned about this very important word yesterday that I said, you need to remember this word. It's gonna carry into our lesson 7. We learned why we can see colors, specifically a rainbow. And Miracle, what was that really important vocabulary word that we learned over the past 2 days? Remember? If you remember, whisper to a neighbor in 3, 2, 1. Say it out loud in 3, 2, 1. Yeah, we learned now why refraction is so important because it allows us to actually see the colors in the spectrum. Miracle, call on somebody else.
Different objects absorb light wavelengths of some colors but reflect others. That's what makes colors.
Yeah, so Miracle and her key details learned why I actually can see that this bucket is orange and not green. Why is this bucket orange? Why does it appear orange? Jadion, go ahead. Yeah, and what happens to all the other colors? They're what? They're absorbed. So now you know why your shirt is pink. Now you know why your shirt is blue. We can now go home, and I hope that everyone goes home and sees their family and is like, I'm gonna tell you why you are wearing a green shirt. And I hope that we can go home and share all of our scientific information. All right. Now, we're gonna move on to the experiment piece. Everyone say experiment. You read all about where colors come from and a rainbow, but we're gonna put it to the test. Today, we're gonna be doing another observation, and everyone say, thank you, sun. Thank you, sun. Because we needed the sun today in order to do our experiment. And what we're gonna do is we've been learning about color, and we've been learning about white light, and throughout our you see nothing. Throughout our conversation about color and light, we learned that light refracts when it goes through what type of object, transparent or opaque? Transparent. And what happens to the light? What actually is refraction? Kion, go ahead. So the light slows down, and then what else happens to the light? Asada, what happens? It bends. So what we're gonna do is an experiment of what happens when white light goes through a prism? Will it bend? Will it slow down? And what are the results gonna be? And what we're gonna start is with a prediction. Everyone say prediction. And I want you to think about what you learned from your small book about prisms and white light and refraction and transparent objects. We're gonna make a prediction under experiment number 2. And what I want you to think about is, what do you think is going to happen when I hold a prism up to white light? If you want to go back and look at those key details you wrote down, because maybe you already found what might happen and your research is going to help you now, I want you to take 3 minutes in prediction for experiment number 2. What do you think is going to happen when we take a prism and we hold it up to white light? You have 3 minutes to jot down your prediction. Ready, set, go. I see Marshada's looking at her key details. She's trying to see if she recorded anything. And I know she wrote down a word prison earlier. And let's hear from a few friends. Actually, let's turn and talk, because I think that I want you to share your answers with your group. Take 30 seconds, share your prediction with, wait, I know we're excited, hold on. I can say share your book. Share your prediction with your group. Ready, set, go. Okay, why?
Because if you put it up to a white light, it'll shine through and make a real.
But why? This is clear. Why would a rainbow show through?
Because the light has every color.
And what, think further. Yes, it's going through. What is happening to the light?
It's bending.
Okay, what's that called? Yes, babe. That means you're all brilliant scientists. Well, now take it a step farther. Why? You all agree on the idea it's gonna make a rainbow. Why do you all think that?
The light has all the colors in it.
Write it, add to it, make your prediction better. Let's have 2 friends share out. Antonio, what do you think is gonna happen? Okay, anyone else agree or disagree? Okay, Kyer, what do you think is gonna happen? What do you think is gonna slow down? Ooh, look at him going back to his notes. Give him some shine. He said, I'm gonna make sure I'm positive. I'm gonna look at my key details. What's gonna slow down going through the prism, Kyer? Yeah, why don't you call on someone? Call on a fellow scientist. Five, four, three, two, one. So the white light's gonna go through here. And Kion, what do you think is gonna happen? Okay, it's gonna be another path. All right, are you ready? Now, I wanna share what your ultimate goal is before we do this experiment. Your goal for today is to summarize what happened in our white light experiment. And you're gonna list a very few important details. Everyone say steps. In your summary today, you're gonna include what steps did Mrs. Lushi take in order to complete this experiment. Everyone say materials. What materials did we need in order to do our experiment? And everyone say outcome. This is a new scientific word that we're gonna use. Outcome is the results. So what happened? Everyone said, what happened? Everybody, what happened? And using our key details and using our knowledge from our text today, you're gonna be able to explain why the results were the way that they were. So everyone say, come out, son. Come out. Please, please come out, son. Alrighty, we do need the lights off for this part. Are you ready? All right. First, I'm gonna go over and I'm gonna take my prism. Once again, we're thinking about the steps. So your pencils should be down. You can tilt your body a little bit. I wanna see what's gonna happen when white light goes through a prism. What is the outcome gonna be? So the first thing I obviously need is I need a prism and I need white light. I'm gonna find where the light is shining through in the classroom. And what I'm gonna do with my prism is I'm gonna hold it up to the white light, and I gotta twist it until I find the perfect angle. Are you ready? All right, so I have my prism, I have my white light, I'm finding the sun, and I'm gonna twist it. All right, I'm gonna do it again. I'm gonna take my prism. Hold on, Miracle, hold on. I'm gonna take my prism. I'm gonna look for that white light. And I'm gonna twist it. Come on, everyone say, come on, light. Come on, light. And I'm gonna twist it if the light will come out. Oh, it's really faint. Do you see it? Yeah. Find it. No. Oh, wait. Alrighty, if you can hear me, clap once. If you can hear me, clap twice. I want you to take 2 minutes, and in this space where it says observation, I want you to jot down some notes. Think about the materials I used, think about what I did, because we're gonna use these observations to then write up a summary report. So take 2 minutes, stop and jot. Think about what I used, think about where I stood, think about the steps I took. 2 minutes. Ready? Set, and go.
How do you spell use?
U-S-E. Take 2 more minutes. Don't stop writing. Just because you wrote down one thing, I want you to ask yourself, was that the only thing Mrs. Lushi did? No. Thanks, Ava. So I want you to think about that. Let's have a bunch of friends share out, thinking about what materials did I use? What were the steps that I took? And what was the outcome? Let's have someone share the materials. And once again, if you hear something you want to add to your observation box, I would pick up my pencil and add it. Kayer, go ahead. What were some materials I used? Okay, let's stop for 1 second. What was that little glass thing called? Say it out loud in 3, 2, 1. Well, I know that part of my criteria for success is to include my materials, and I now have gone over what that little glass thing is called. So if I don't have prism, I'm gonna write down the word prism. What other material did we use today that we couldn't have done this experiment without it? Sincere, go ahead.
Sun.
Yeah, the sun was a material. We needed the sun. What was the first thing that I did? Akir, what did I do first? Did everyone hear what Akir said? Yes. What did I have to look for? The white light. I had to look for the white light. So the first thing that I did as an experimental scientist is I had to find the white light. What happened after that? And once again, if I need to update my notes, I'm doing that now. Logan, what did I do after that? What did I turn around? I took the white light, I found the white light, and I twisted it until it went through my prism. What happened next? Jamil, what happened next? Yeah, so when my white light went directly through my prism and I twisted it, what was the outcome? The outcome was a rainbow. What was happening to the light when it went through the prism? If you know, say it out loud in 3, 2, 1. Okay, the light slowed down. What else did it do? It bent. What is that called? What is that called? Refraction. Wow, I can now explain how rainbows are created. When white light travels through a transparent object, it becomes a rainbow. Now, I'm gonna give you 2 minutes. If there was any of that you feel like you wanna add to your notes, because you feel like you wanna write the best summary and most detailed summary that you can, take 2 more minutes, add to your notes. Ready, set, and go. Add to your notes. Thinking about our criteria for success. What do I need to include in my summary? Please put your name at the top of your exit ticket in 5. Missouri, did I forget to give you one? I'm sorry. In 4, put your name at the top of your exit ticket. In 3, put your name at the top of your exit ticket. In 2, and in 1. Can I have someone read at Good Scientists, please? Logan, nice and loud.
Good scientists write summaries after their experiments because it helps them remember what they learned and explain their results clearly to others and use that information to make new discoveries in the future.
We're gonna write a summary, so we will be able to, as scientists, go back and share what we learned with others. Push your chair in. No, thank you. And share what we've learned with others in order to make 5, 4, thank you, new discoveries later. Your exit ticket is going to be to write your discovery. And included on your exit ticket is what you need for today. Everyone say materials. Don't say this one because it's long. You need to include the steps of the experiment. You need to include the results of the experiment, why the results happened using your notes. Now, if you also want to go back into those key details to explain why we had our results, go back in and look at your notes. Now, there's one last thing you need to include today. Everyone say transition words. Everyone say transition words. Transition words. Within your summary, you should be using 3 to 4 transition words to explain the steps we took and what happened. Point to a resource around the room that you can use in order to maybe remember what the transition words are. So as I'm writing, I'm gonna be thinking about using 3 to 4 of those words in order to write my summary. Give me a thumbs up if you've got it. We are going to take 7 level 0 minutes to write a summary, including all of this information and our 3 to 4 transition words. And you can go ahead and start writing. Go. Now, if you finish before the timer goes off, there is a challenge on the back, and thinking about how this experiment could be different depending on maybe different weather, but do not do that until you are done your exit ticket. Your exit ticket is the most important. The challenge is for when you are done. And before I even think about going to the challenge, I'm gonna check my criteria for success to make sure that I included every single one of those details inside of my summary. You don't feel like you're up for the challenge? I feel like you're up for it. Alrighty, if you can hear me, clap once. If you can hear me, clap twice. Please take your exit ticket, put it in the corner of your desk.